In this video, let's tackle the 2012 AP Calculus AB free response question number 5. Specifically, let's do parts B and part C. So part B is asking you to find the second derivative. So let's do that part first. So they give you the first derivative. So the second derivative, let's just let that constant hang out. The derivative of 100 is 0. The derivative of negative b is negative 1. And then we need to do implicit differentiation because b is a function of t, so every b has a t in it. So the derivative of b is going to be db dt. That's just like implicit differentiation when we say the derivative of y is y prime. The derivative of y squared is 2y, y prime. Same logic here in this problem. Now, this says find the second derivative in terms of b, and I have a db dt, which I can't have, but I know that db dt equals 1/5 100 minus b, so I'm going to plug that in. So I have negative a fifth times, and then I'll do my 1/5 times 100 minus b, which is my db dt, right? My final answer is negative 1/25 times 100 minus b. That's my second derivative. Now, the second part of this question says, use the second derivative to explain why the graph of b cannot resemble the following graph, and that's this graph over here. Well, in this graph, you'll see that our values of b are bounded between 20 and 100. So let's take a look at what that means about this. If b was 20, then 100 minus b is going to be a positive number. It's going to be 80, right? So that would mean that the second derivative is negative, right? Because I had to multiply by the negative 1/25. Now let's look at the high end. If b was up to 100, then 100 minus b is going to be 0, and our second derivative would be actually equal to 0. And everything in between 20 and 100, for all those values, we know it's going to be negative, right? It's most negative at 20, and it gets less and less negative until it gets to 0 here, and it's going to turn positive after 100. But this graph has a concave up region here. If the second derivative is negative, then that would mean that it's concave down for all values. So this, what we found, would imply that our graph is concave down for all values of b between 20 inclusive and right before 100, right? But that's not representative of what we see here. So that's why it cannot be the graph. That would be a proper justification. In part C, it says use separation of variables to find y equals b of t. So let's go ahead and just separate the variables. That means get all the b stuff on the left and all the t stuff on the right. You'll notice in this question, which threw people during this exam, I still remember when this question happened, and this type of question has popped up a couple times, so I really want to emphasize it as one that's important. If you don't have a t, or if you didn't have a b, then, just get all the constant stuff on one side, and all the b stuff needs to be on the left. So that's easy. 1/100 minus b is going to be on the left. And then on the right, well, I just have the 1/5 there. Just leave that constant over there. And now, because I'm separating the variables, I'm going to take the antiderivative of both sides. Okay, now I'm going to go ahead on the side over here. I'm going to figure out the antiderivative of 1/100 minus b, because this is actually kind of a u sub problem. U equals 100 minus b. du is negative 1 times db, right? So that means that we'll substitute, instead of our db, we'll have a negative du. So this is the integral of 1/u times negative du. In other words, ln absolute value, and let me just take that negative out, negative absolute value of u plus c. So that's negative ln absolute value of 100 minus b plus c. The antiderivative here we just found was negative ln absolute value of 100 minus b. And I'm not going to put my plus c because I'm just putting that on the right side, of course. The antiderivative of 1/5 is going to be 1/5 t, because the t was my variable on that right side. And so now they tell us that b of 0 is 20. So let's go ahead and put that in. negative ln absolute value of 100 minus 20, 100 minus 20, because b is 20, equals 1/5, t is 0, plus c. So we have negative ln of 80 equals c. So now we're left with negative ln, and I can take off the absolute value. See, I see 100 minus b for everything in between 20 and 100, which are my bounds. You know, the absolute value of 100 minus b is just going to pop out the exact 100 minus b. So I'm going to just change that to ln 100 minus b. Okay, I'm going to take the absolute value away because all those numbers are positive on the interval from 20 to 100 when b is 20 to 100. That equals 1/5 t plus c, which is negative ln 80. Let's go ahead and get rid of this negative there. Let's divide both sides by -1. So ln 100 minus b equals negative 1/5 t plus ln 80. Now let's go ahead and base e both sides. So e to the ln, so we just have 100 minus b equals, and then we have e to the negative 1/5 t times e to the ln 80. E to the ln 80 is just 80, so we have 80 e to the negative 1/5 t is equal to 100 minus b. I'm going to scoot the b over to the right. B equals 100 minus 80 e to the negative 1/5 t, and that should be our final answer.